Okay, ladies and gentlemen, apologize for the brief delay there. Tonight's was a kind of quick infill lecture. We had the opportunity to bring Dr. Pongsak Chai Su Parismikkel over from Chicago Institute of Art, and he's also got an adjoint position with the University of Kentucky Center for Sustainable Cities. We're getting microphones all lined up here. Dr. Pong has his PhD in architecture from Illinois Institute of Technology in Chicago, his Master's of Science in Community and Regional Planning, and his Bachelor of Architecture from University of Texas at Austin. His presentation tonight will be on interoperability and the interface and the process of using building information models to conduct parametric energy simulations. And I think we're getting close to having our microphone all set up. As always, I'd like to thank Idaho Power, Northwestern Power, University of Idaho, and Montana State University for hosting the fall series. One last announcement, the talk by Dave Hewitt in the New Buildings Institute was rescheduled for December 4th. 4:30 to 6 p.m. Thursday night, and that'll be the final in our fall series, and more in spring. So, with that, thank you, Dr. Pong, for coming out.
Thank you.
And the floor is yours.
Thank you. Can you hear me? Can everyone hear me? I appreciate thankful to Professor Kevin and the team from the Idaho lab.
You might want to speak up just a little bit for me.
Okay.
Thank you.
I'd like to thankful to Professor Kevin and his in the Integrated Design Lab for inviting me to talk about optimizing climate responsive design by using BIM and energy simulation.
You're going to want to make sure that you don't move the mouse too much and then just stay on that green arrow.
Okay, fine. Okay, I'd like to start with we call bioclimatic data. And I give a credit to, I used to work with Troy, Peter, my colleagues, try to develop the software that can be able to generate interfacing with the climate environment. Like you can see that there's a line here. This is an outdoor temperature, and there's a curve that pop up. This is a radiation resulting from the temperature that occur at the same time. This is an hourly period at 1 day, and just show you example that how we can approach the design to this bioclimatic. So this is a bioclimatic zone in Chicago. You can see that energy efficiency is not only mean save energy only, but it also mean have to maximize human comfort. And in January, which is probably the coldest winter month, the data is for around this area, which is the coldest, and also have a highest humidity. If you see the chart here, that's divided to the four parts. This part is have a high temperature, but also have a high humidity too. These two are different, and this in this section, this have a lower lower temperature, but have a low humidity. So to show you that how architecture design approach is different from engineering. Usually, architect always deal with this kind of thing more than engineer. So if you can, this kind of suggests you that if kind is a chart that suggests how you can design that, how you can fix the thing, how you can adjust, like the building is like the fabric, it's like the code. It can be adjusted. The body can be adjusted. So that's how we approach the bioclimatic. And if you can see that there's about in the 12-month period, you can see that all the starting moving from the left to the right, by starting from the bottom to the right corner and the bottom right corner, and move up to the top to the left. That's when the temperature is getting higher. But in this one is in January, and then in this one is in May and June. You can see that they start moving to the comfort. So anything that not within the comfort zone, it means have to be adjusted. So now we know how to solve the problem. So by finding many means, for example, if it's too cold, we can provide the radiation. If it's too hot, then we have to provide some cooling. Can be passive cooling or mechanical cooling. If it's the humidity is too high, have to provide some, maybe have a wind, enough ventilation to reduce the discomfort from the moisture content. So you see that it's starting. And then come back again, because the climate in this country or in this part is divided the winter and then summer and then winter. So the curve is kind of going curvature, kind of symmetrical. And the mean radiant temperature is mean that suppose we are in this room. Right now the outside temperature is cold, but I'm staying here. I have a heat. I receive the heat from the heater or from the along the fin tube here, provide the heat to me. So I feel warm, but because of the outside temperature is cold, so the cold and the warm is kind of reached at the arbitrary line between the cold and the heat and the cold. It's have a mean. It's called mean temperature. So it can be right now. It can be between 75 degree and maybe outside maybe 50 degree, and maybe match each other at the mean. Another thing that I like to introduce, or have anybody heard about this before? It's called solar air, because there's in order to provide a human comfort, solar radiation is one of the most important thing, and the other thing is that it's air temperature. That's also important too. So the methodology that we did is to combine these two together. It's called integrated. It's called solar air together make it. Because if when you look at the bioclimatic chart, if the temperature is too low, and you can provide solar radiation either heat gain or heat loss. But if you not provide the wind can reduce humidity too. Humidity can produce the discomfort from the heat. So if the air can add on into the solar and provide a more effective solution for this. We call that the solar air index. So if this is a kind in the winter time, because we can use the data as a representation. Like I can talk about this in the BIM or building information model. Is that we represent, like in January is the coldest month for Chicago. So we say January 21st is a representation for the winter. And then we can say that July 21st is a summer for the Chicago. Now we got a representation. And then you can see that because according to the theory of the there's theory that it become a fact now, is that if you have a volume like this is a volume, and suppose it is a square. If the surface that confront with the temperature outside, because the surface is an envelope that protect us from the environment, from the severe environment. So if this surface of four sides, if we can reduce to the minimum, then we can save energy. This is according to the theory. And if the inside we have a high volume, for example, we have a big space, the high ceiling, and the volume inside compared to the surface outside is greater than surface outside, then we save energy. This is its theory has been proved now. So we call this surface to volume ratio. And if according to the theory, say that if designer or architect or engineer maybe can decide that make the building have a high volume to surface area ratio, or minimize surface that confront with it, then we can save energy much better. It's called optimization. And then another thing that we want to look at is that because the comfort is not in the winter time and the summer time. If you look at the graph and the curve, no matter what city or what country, usually the curve of the heating and the cooling will intersect to each other. The intersection between the heating and cooling is called balance point. So anything that fall be up higher than balance point, suppose you have a heating and cooling cost at the maybe in July. July, summer is July, and winter in January. And when the curve is cross each other at probably, let's say, in April, then the point at the April, you can say that anything that higher or because when we get the heat, the temperature will be higher. So anything that data that higher than that point, we call overheat, which is this one. This is overheat. And then anything that fall below the point, the balance point, we call underheat. That's when underheat means we need more heat. We need heat again. But if overheat, we want the heat to be extracted. So this is like the concept. So these are the temperature for the is a hourly temperature, but for the entire month, and the curve is very similar to And this is a sky dome, and it's amazing that the natural environment is so amazing. Is that the sky dome that cover this building. In fact, the project that I used to work on, when I put the project under the sky dome, this is solar radiation according to the time of the day, and also it contains many information inside. On this line, it tells you about what's the altitude, the height of the solar position, and also it have a graph here say that what is you can plot this and then you can find out what is the daylight factor is according to the solar radiation. And this is a azimuth. It's been azimuth between the angle within the horizontal plane. And this is the altitude, which is the vertical plane. Okay, so this is just an introduction to the about. Next thing is that I want to talk about the building information model, and in the energy simulation, there are categories that step by step. First one is the climate or the weather data, which I have introduced to you, and the second thing is the building and the model. Model is represent the building. So we can say that because building haven't been built yet or have not been solved yet, so we cannot say that the building have been touched by us. So we have to say that we represent, we can abstract our work. Now I have to change the file into to the BIM file. So I'm going to end this session. Thank you. So next thing I'm going to talk, according to the title, is about the information model. What is the definition? What is the object-oriented system mean? What's the interoperability? Why interoperability is so important? What's the open standard? And coordination. All of this is a property of the building information model. It's a character of the building information model. And why it make the building information model so popular nowadays. So this is a model. The project is called Brookfield. So I used to work on this project. And if you look at this one, you probably cannot tell that what's the difference this from a 3D model or typical model or typical 3D whatever. that contain no information. But this one contains information. This one this is a photovoltaic inside. And if you use this, if you click on the photovoltaic, it won't work because of the loop here is protect the sun to the photovoltaic. That's why nowadays they call building information model as a smart model or building intelligence, because it can move itself. It's called kinetic. Kinetic means it can move and it can change and it can respond, especially to the climate or to the environment. And also another character is a parametric. It means it's never fixed. It's always changeable. That's very important thing that about BIM, that make a BIM very important and very and the definition of the model is a pattern. This one I got from the person I don't know Venkatasan engineer who gave a definition of the model. So another in a BIM can be very successful nowadays because of object-oriented system. Because before, the reason that we don't have BIM before because there is no object-oriented system. It's just been created recently, probably 10 years ago. And the character of the object-oriented building system is very nice. One is an integrated building design solution, and especially for AEC, architecture, engineering, and construction. This is very important because that makes me very interested in the integrated design solution because of this. And second thing is contain a model phenomena. And the third thing is it can represent the object as an object. Like it can tell that this is an object, this is a verb, this is a noun, this is a plural. And because in order to achieve the object-oriented system, you have to classify what is an object, what is a method, what is a system, and what is an event. And it also contains a data abstraction. This is the most important thing of the BIM that I pursue nowadays. Maybe somebody might have a different opinion because for me, but for me this is very important. Data exchange model, data extraction, data mapping, and display and queue information. Because this I think you can extract information from the BIM and put into the energy simulation. Otherwise, there's no way to. Otherwise, there's no way you can achieve that. Because to get information from the BIM, you have to extract and mapping and query and put in the database before sending to the energy program, energy simulation. Is that clear? This is, for example, this is you see this? You see this point? It can move itself. It's called transformation. Like the model can transform, either to parametric or to kinetic. It can move, like you can make a building move by using this method and system. The building can twist and move. I used to work on the project for SOM, and they provide me with a model, and I twist the model by from the rectangle form as a footprint, and the building is about 111 story high. It twists itself up to the top, and the change is called transformation, and also moving too. They achieve two things: transform and respond to the climate. Because when you twist, you change the orientation, so the response to the climate is changing too. And this the house that I used my project that I've been designed a long time ago, and I start from the image, which is a perspective drawing, and I try to gradually change, transform into the BIM model. So this is supposed to be the BIM model. So this is a definition. All this is very important. That mark as a green or green. It's tell about the definition and the concept of the model, and it's very important to our field, because architecture engineering have to deal with something virtual reality. Design before it come up. If you want, you can copy later on. This is talking about if you look at this is supposed to represent the photovoltaic, and this angle can be changed according to the sun that hit to the surface of the panel, and BIM can bring its element that represent and relationship which return the parameter that compose of this kind of thing. That's another important about BIM. It can represent, besides represent the element, it can bring the element into the parameter. And this parameter, because of all this, nowadays we have it's called there's an arcade or those people who do the business with the construction, manufacturing. Nowadays they produce the CD, which is because of this they got the CD that represent the product, each of these. Oh. Like this one, this is an object. Like you can make the door, change the size itself. Inside here, this called parameter. This is a property of the material or elements, and this size is called parameter. You write a short script and tell the program that you want to make an object as a parametric, And then you can move the door. The door can swing, move, or they can move. This is a sample of the script that it tells you about this door. Said that if the length is less than 3 meters of the wall, the door, then say like that. But if the length is greater than whatever, let's do that. So this is exactly the same as building code. So if you can write the script like this and propose to the building code, you don't have to spend the time try to collect every word, single word. You just run the script and you get the whole support, and then you can provide to the city with the building code. And I guarantee you that every of your drawing single sheet, because now before you have to suppose it's 100 or 1,000 sheets. You have to go to every single sheet. It's just, but now with this system, you can run that without have to worry about that all the 1,000 sheets or 100 sheets. It will comply with the building code or not. This is very powerful. And another concept, important concept, is a coordination and collaboration. And you can call import-export is a part of a collaboration. Also sharing. And without data sharing or without coordination, you cannot achieve the interoperability. And then talk about the standard, now the open standard. In 1995, IAI, International Alliance for Interoperability, developed a data model called IFC, Industrial Foundation Class. Because BIM has to be open standard, and then have to be able to share. That's why it's possible that we can make two things which is totally different come together, energy and building. Because in fact, the one thing can be combined. It's so bad now. So if you look at this, this is the way how I tell you open standard. This is what happened nowadays. It's very confusing. Do you see the line? This line is very confusing. The line can represent the communication or interaction or working together. Maybe this may be 1,000 or million lines, but you get nowhere. You still the same thing. But if you have a shared data model, which is one of the characters of the BIM, you see how neat it is? Just one loop. You get everything communication together. That's why they try to achieve this one. And try to create it's called standard. And now the GSA and also government agency or Department of Energy try to work toward this open standard. Now, interoperability. IEEE define interoperability as the ability of two or more systems or components exchange information to each other, or to use the information that has been already exchanged. This is a definition of the interoperability by IEEE. So this is what happened. This I extract from the BIM software. I use a Revit, Autodesk Revit which is a BIM software, and I extract data information. Each of these is a one represent one table, one data set. So all of this is combine this, and then when I extract this, it's stored in the database. Before it's send it to the energy program, which is run to this one, and this one create an energy input file. And this one is tell you about what is happening about energy input file. And this one is going to run the energy input file, simulate the energy input. And then what happens next is it's going to create a file format. And because of the file format and the protocol, it can move to another step by creating the interfacing with the user. So everybody can see this graph that represent the data that simulate from the energy program, send to this one, become a graph. So this become a loop. So you're going to produce a graph probably every 5 minutes or 10 minutes. Going to provide the graph and chart for the building energy use. That means that from now on, everybody can know what's going on with the building. Now we don't know, but suppose I put this in the somewhere here, in the monitor. Everybody can look at it and understand that okay, what's going on happen right now, or maybe predict in the future, or maybe what's happened in the last 48 hours. Did I click something? So this tells you about what's the benefit of the interoperability. And I think that, are you interested about the what's the difference between the BIM and CAD? Are you? Or you do? There's a significant difference between the BIM and CAD. Do you know what the CAD means, right? So the original of the computer assisted design, or CAD, is to automate the task of drafting, not design. And the focus is to represent the 2D geometry, while graphical elements such as, so it's to represent the element of line, curve, whatever, which is an attribute. It's not an object. So to establish some meaningful behind graphical element, the concept of layer and block were introduced. That's why you see that all the CAD have a layer and block because of this, because of the element. So now, because if you want to move element, you're going to get 1,000 of elements, which is very inconvenient. That's why they have to group it as a block or layer. And from 2D, now they start to make it more complex by cause relationship between an element and become a 3D. But the 3D, in this one, is not a BIM. You know why? It's a 3D now. Now from 2D it's become, this is a 3D. This is a real 3D too. but it's not a BIM because you know why? Exactly, because it has no information inside. You cannot extract any information. You just all you get is a graphic, but some data inside there, nobody knows what's happened. So now there's another it's called immersion of 3D CAD plus parametric. Now it's getting have more data now because the parametric is a data. And now it's create a well-coordinated pressing reposition geometry in support of visualization. Now not only visualization, now we have something more capability than just a visualization. And now it even make a visualization more better than before. Like I try using try to render to the BIM. It's have more meaningful than before, even though it's the same graphic visualization. But by the have a data inside, amazing. It have more. It's like it have a mind inside. So this is done to somebody who done somebody not me, somebody they create this to the architecture desktop object model. But architecture desktop is not a BIM, but it have something like similar to BIM, but it's not really BIM. At that time they call ADT. This was interesting. This is what I mean. This is a project that I'm working on. It's called ADN. And this is inside the room and the building. And by all is a CAD drawing. And when I transform it to the BIM model, and then I render this, amazing. It's a lot better than before. And it can even change too. When it can update itself too. I don't have to render again. When I change some information, it can update itself. For example, if I render one, if I suppose I put the material for this curtain wall, and then render one time, and then next time I change the curtain wall into something else, some window or whatever. It changes by itself, doesn't have to redo again. It's an ADN office. Because at that time it's important to the project because we want to sell to our client that we want to make an interior say that because the client want to know that if they change the light bulb, the light bulb from the in can to the fluorescent or whatever, or to the exotic light, what the mood or what the feel of the space going to be. That's why it's important for us to it's very useful and be able to support and make our client happy. And this project is also is a lab project, Griffin Lab, and this is also interesting too because on the rooftop here there's a seven mechanical equipment rooftop unit that provide the cooling to the space below. The lab is a 1 story high. and they put all these rooftop unit into the on the roof, and down beneath of this rooftop, they have a hole that the duct can fit on, and you know, with BIM it's so amazing, because when you say that attach, it attach, and then also it won't come out, because if you see that some drawing that you can see that there's a problem with the core. When equipment fall down and cross the line with the architecture, they call architecture and engineering was crash. They call crash. But because of it, but because you have a BIM, so now everybody happy now, no problem. And this the project about this is kind of trying to find the what is the optimization form or shape of this building. This is in Chicago. There's a question. The answer is that when I talked earlier that optimization is mean you have to minimize the heat gain in the summertime and maximize the heat. Minimize in order to achieve optimization of the shape and the form of this. I have to minimize the heat gain, minimize heat loss. Is that right? Maximize the heat gain in the summer. No, maximize the heat gain in the winter and minimize the heat loss in the summer. That's a achievement of it. So if you run the energy simulation and find out that what's the optimization point, then you can know the shape of the form of this building. So this is another benefit. Oh, this is a project that from SOM that I mentioned earlier. This one it's called like a template, this is like a structure, one piece of template, and this is a glass. So you can specify this glass according like that. It can be a low E or single glass or double pane, and this will specify the material like concrete, steel, or wood, and then attach it together, and then mash it, and then screw it with a beam, so it's become an object, one piece object. And you know what? The building have a center in the middle. That's why this is the center of the building. So when you put this piece attached to the surface of the building, and match this point with the center of the building, and then you say rotate. You know what you get? You're going to get 100 and 1,000 story that twist itself and changing itself. Thank you very much. Does anybody have a question?
You were talking about finding an optimization point, with regard to the building volume and the outside surface area. I wonder, as wonderful as BIM is to have all this intelligent stuff, I wonder if architects aren't going to be threatened by that in that, you know, like it's almost taken away some of their creativity in wanting to, you know, have the building look a certain way and things like that. But just more of an observation, I guess, than a question.
In fact, this is an architecture job, I think. I think that is an architecture role. Because there's a role that we try to separate. In fact, it's integrated, but there's a role between an architect and engineer. Architect do this, engineer do this. But I'm very happy with the integrated system. But I mean, it doesn't mean that every architect can do the job of engineer or engineer do the job of architect. It means that everybody knows what they're doing, but just collaboration and work together.
Could you talk a little bit more about the process you use for connecting building information models with energy simulation?
Oh yes. So after you extract data from the building, from the drawing, from the model, you extract and then you put into the database, store in the database, and that way we organize the data information. And then you use a file format to take the information from the database and bring into the energy simulation. We should take this and then create the input file, because energy have a user input file. Then create input file, then can run simulation and produce the result data. Then have to build another interface to kind of take this data to produce as a show to the public about the graphic information. That's what we do.
Do you have anything that displays that?
Yes, I do.
There's probably a lot of people in the room who are using Revit now and trying to figure out what are they going to do if they want to export to Energy Plus or some other energy simulation tool. What do they do?
Should I show in the computer?
If you have something visual, that's great. Otherwise, you can just talk to that question a little more.
Yeah.
Actually, Revit, Autodesk actually bought Ecotech, and I think it's going to become a part of the Revit.
I was really surprised because Revit they have a data mesh, so it's very intense. But Ecotech take the data grid, which is the scale is different. So I was very surprised by Autodesk bought. I don't know.
I think they bought it for competition and just do it on their own.
But I don't see Ecotech as an energy simulator necessarily. It can help you with some loads analysis. You can use it to export to lots of different tools. But on its own, it's not a simulation. It's not an energy simulation engine. I don't know if you have any comments about that, Dr. Pong. But I think there's just a lot of question about how you get Revit to interface as an energy simulation tool. You know, how do you interface with an Energy Plus or another DO2 based energy simulation tool?
That I mean, each of the program or software have their own. That's why they try to make it open standard, try to make everything to become one, which is probably almost impossible. But IFC and IAI, they try to do this, try to make it open standard. Even NIST or GSA, this agency, government, they try to make it open standard. But I mean, I heard from people in the field. They said, how can it become open standard? Some information they cannot be shared. See, some information they have a secret inside the firm. How can they share that information? Like the technique, because it's very dangerous. If you take information, you take a technique from them too, unless they're willing to give to you. Otherwise, if you take by, it's kind of dangerous too. So it's not have no easy question for this, no easy answer for this.
Are there, if you go through this database, you have your BIM model and, get it in the database and export it into whatever energy package you do modeling. Can it go back in, like if you make some adjustments?
You don't have to. You don't have to go back. Before I thought that, before I told, when I make a presentation, I thought it should go back. In fact, it doesn't have to go back. It's nowadays they have it's called iterative or recursive. You know what I mean? Like iterative is like this, recursive is like this, right? You don't need to go back. You just need only one time, and it saves a lot of. This I'm so happy because thinking about just one loop is almost crazy. You then have to bi-directional. Oh. But now we can achieve because of technology, we have a knowledge to do that now. So now just one loop, and then we can achieve it. And it can always come back because loop is being come back. So you don't need to loop like this again. You can just one time. That's very wonderful. It's called. I heard it because of one. I talked to the guy. He's a computer guy working in the school. I talked to him, and then he answered me about because the loop had to go to the end. Then okay, suddenly I understand. But I appreciate that. That's another one of my final. Because it's going to save me a lot of effort.
Are there any other questions for Pong? Well, with that, let's see here. Take this down and make it official. Thank you, Dr. Pong, for coming and presenting, and thanks to Idaho Power and Northwestern Energy for making the events possible.